Welcome. Some people claim that burning fossil fuels is good, in that we get abundant, cheap energy. But that is only true when you have heavy government subsidies. If you remove the government subsidies from both the fossil fuel industry and the renewable industry, the renewables come out cheaper. So you're paying high government taxes in order to save a few cents at the pump. That doesn't seem like a good deal to me. Others claim that all the carbon dioxide put out into the atmosphere is good for plants to grow, and to some extent that is true also. However, only under very limited circumstances, as we shall see later. So let's take a look at the problem of burning fossil fuels. Just about every human endeavour involves some impact on the local environment, but none have quite the same level of impact that the extraction and use of fossil fuels do. There's the obvious destruction of the habitat. When you have a thing like an open cast mine here, whatever was here before, whether it was a mountain, a forest, or open fields, are not going to be re-established in this area. Whatever lived there before, whether it was human or animal, will not re-establish itself ever again in this area. When you have massive excavations like these, it often leads to water pollution in the local area, which affects all the wildlife in the area, including the human life and health. We've all seen the devastating impact of oil spills, not only on the local wildlife, but also on local economies. Remember what happened in the Gulf. Fossil fuels are energy dense, which is one of their advantages, but that means they can easily catch fire and cause a great deal of damage as a result. We've all seen pictures of the results of fracking where local water supplies can be set on fire. Similarly, oil rigs and oil refineries catch fire with monotonous regularity. But what we're mainly going to deal with today is what we dump into the air when we burn fossil fuels. The obvious thing at the moment is smog, which is causing a lot of health problems in urban areas, but also the issue of global warming, where greenhouse gases are dumped into the atmosphere and cause changes in our climate, which are generally undesirable. Fossil fuels are basically carbon compounds. For example, coal is just mostly pure carbon, with a few impurities associated with it. Oil is a complex mixture of paraffins, naphthenes, toluene, and some impurities like sulfur, nitrogen, nickel, and vanadium. Natural gas is primarily methane, with a little bit of propane, ethane, and butane mixed in. So when you burn these, what you're really doing is you're burning the carbon in these mixtures. And each one of these fuels has a different result of being set alight. What happens when fossil fuels are burned? Well, burning is oxidation. So coal, for example, you take the carbon from the coal, you add oxygen to it, and you end up with carbon dioxide plus a lot of extra energy. For natural gas, you're primarily burning methane, which takes a couple of oxygen molecules and produces carbon dioxide and water vapor. So you increase the carbon dioxide in the atmosphere, if that's where you dump the results of the burning, and water vapor. But you lose atmospheric oxygen. What you have here on the right is the decline of atmospheric oxygen over the last 30 years. We've lost something like 600 parts per million, or 0.3% of our atmospheric oxygen in that time. So these things have consequences. First of all, the water vapor condenses out. It only lasts in the atmosphere for a few hours, so it's generally irrelevant. The carbon dioxide is released into the air, and that can last anything from decades to centuries. However, about 35% of it is absorbed by plants. That increases the amount of carbon dioxide stored in plants by about 0.5% per year. About 20% of it is absorbed by the oceans, and that increases the amount of carbon dioxide in the oceans by about 0.2% per year. And the rest of it, the bulk of it, in other words, remains in the atmosphere. That's 45%, or increases the carbon dioxide in the atmosphere by about 0.5% per year. The important part here is it's per year. These contributions accumulate, so it gets worse as time goes by. First, let's take a look at the effect of increasing atmospheric carbon dioxide on plants. Added carbon dioxide promotes growth of plants if and only if You can control the temperature within certain ranges, the water level, the nutrients, and light levels. So you get a situation like this, where in an ordinary situation you get a certain plant of a certain size. However, if you increase the level of carbon dioxide, you get an ever increasing size of plant. However, under normal conditions, when you have more carbon dioxide, temperatures start to rise. That dries out the soil and you actually get a stunted plant. Even though you've got higher carbon dioxide, you get less of a plant. And this leads to crop failures. An example is the temperature. Each plant has an optimum temperature of growth, and this is just an example. And the optimum temperature of most plants is around about 75 degrees, between 70 and 80 degrees. Temperatures start off low, the plant doesn't hardly grow at all. As it gets to this optimum temperature, it will be growing at the fastest rate of all. However, if you go slightly above that temperature, the rate of growth drops off considerably. And that's one of the problems, is that with more carbon dioxide in the atmosphere, the temperature is going to rise and your plant efficiencies are going to drop and you're going to get more crop failures. Let's take a look at the effect on the oceans. Absorbing more carbon dioxide into the oceans cause the pH of the oceans to fall. That's becoming more acidic, or the process of acidification as it is called. You can see measured quantities here, and it's been steadily dropping for the last 40 years. Now, this is one thing that a lot of people get wrong about this. They say, oh, well, the temperature is going up, so the oceans are going to outgas carbon dioxide. If they were outgassing carbon dioxide, the oceans wouldn't be acidifying, they'd be getting more basic. And so this proves that the carbon dioxide going into the air is nothing to do with the oceans. It's to do with us burning fossil fuels. And that is backed up by isotope measurements as well. One of the things it affects particularly are the small creatures that have shells. The shells do not form readily in more acidic conditions, and so the creatures don't have the protection that they would normally have. And this affects the whole food chain in the oceans. It also affects corals, makes them more vulnerable to all these other problems that corals have been having the last few years. So what is the effect on the atmosphere of dumping all this extra carbon dioxide? Well, of course, the carbon dioxide content of the atmosphere increases, and this is the famous Keeling curve showing that increase over the last 60 years or so. If you compare this for historic levels, the dashed line here is where we are at the moment, about 420 parts per million. You can go back 10 to 20 million years before we have carbon dioxide levels that we have currently. And that should be very concerning. The greatest concern is possible futures, which you see here over on the right. The desirable thing is to try and curtail carbon emissions in the next few years, so we don't go traveling up either the orange, red, or purple lines here, which would be disastrous. Because of the extra carbon dioxide in the atmosphere, we have an increase in the greenhouse effect. This is warming due to the trapping of IR radiation. And when you do that, the global temperatures go up. You effectively put a blanket over the Earth and not allowing so much of the heat to escape to space, so our temperatures go up. And you see here over the last 160 years or so that the temperatures have gone up quite remarkably fast. Well, just how bad is it? How much carbon dioxide have humans produced? It's been estimated that since the beginning of the Industrial Revolution, we have dumped 1.5 trillion tons of carbon dioxide into the atmosphere. Because of these other mechanisms that remove them over time, of that, 320 million tons of it remain in the atmosphere. About 21% of the current atmosphere is therefore carbon dioxide. That means we've lost over 500 million tons of oxygen from the atmosphere, mostly in the last 50 to 100 years. That means we've lost 0.3% of our atmospheric oxygen. It might not sound like much, but it's starting to become significant. We can certainly measure it, as I've shown earlier. So what conclusions can we draw from all of this? Higher carbon dioxide levels may help some plants to grow bigger, but higher temperatures and lower soil moisture actually stunts their growth, which can lead to crop losses overall. Ocean acidification is disrupting the ocean food chain, and 30% of the human population rely on fish as their source of protein. So this is not good news for us. In the atmosphere, the extra carbon dioxide traps more IR radiation, causing temperatures to rise and disrupt the normal weather patterns, as we've seen quite spectacularly in the last year. So I'm going to leave you with just one thing to think about. Every atom of carbon you burn is one less molecule of oxygen for you to breathe. Think on that for a while. Stay safe, and goodbye until next time.